So moving along with this lesson, now we're on doing the critical value area and the p-value method with proportions. So we had mean, and a lot of the steps are going to be the same. The difference is the type of data. We're going to be looking at categorical data. Okay, for mean, we are looking at quantitative data. So that's one thing you're going to need to pick out in the test or quiz. Read the problem and decide, is this categorical or is it quantitative data? Okay, so we're going to be looking at proportion. First, we're going to do the critical value method. Okay, so when you're testing a mean, we're testing a proportion, still need your null and alternative. This time we're going to be using the P for proportion instead of the mu symbol in our null and alternative. The null is still always going to be equal to. The alternative is less than, greater than, or not equal to. After you have your null and alternative, you're going to draw your curve and decide what your critical value is going to be. Okay, so much is the same as testing and claiming about a mean. We do have the condition, and this is to make sure that our sample size is large enough, and that's what this condition would be. Sample size times our population proportion, sample size times 1 minus our population proportion. If both those values are greater than 10, it's a valid test. Okay? So just like before, we're going to assume all conditions are satisfied. Okay, so conditions are always going to be satisfied moving forward for this course. Now for the critical value, I simplified this a great deal. Okay, I simplified it to 4 values, and the only thing you need to worry about is our confidence level is either 95 or 99%, and either 2-tail or 1-tail. Okay, so I'm not giving you a big chart to look at. This is what you need to have in your notes and be able to look this up when we decide what our critical value is going to be. Okay, so simplifying that a little bit for you. Okay, so now we have our null and alternative. We have our curve drawn with our critical value written underneath. We know which side's the reject, the fail to reject area for the null, and now we have to calculate our test statistic. So we have p hat, 1 minus p divided by the square root of p times q divided by n. Now a lot of these things you should know. Sample proportion is our p hat. P is the proportion claimed. That's going to be the proportion that's in our null. And alternative, it's the parameter. The q is the complement of p. Okay, so p and q are going to add up to 100%. Okay, so kind of like you could just do 1 minus p, and that would end up being your q. N is the number of trials, and plugging all that in, that will give you your test statistic. Now I also would suggest maybe putting that top part in parentheses. If you're someone who's not want to plug these all in at one, plug that whole formula in at one time, make sure you have parentheses around that top part. Okay, so there's all the pieces we need. So let's do an example. The roadkill bookstore owner was upset about a claim that mid-sized cars with airbags that get into accidents have less than 7.8% of their riders hospitalized. The owner wanted to prove this claim wrong. He believes it is much higher. In 821 crashes of mid-sized cars with airbags, 46 resulted in hospitalization of the ride. Testing at 99% confident, is the claim about the cars correct? And is the owner correct about being mad about the claim? Okay, so we're going to look at this. First thing is writing out our null and alternative. Okay, so I have my null being P is equal to 7.8%. Okay, and our alternative, we're testing the claim, okay, that the accidents have less than 7.8% of their riders. We want to see if that claim is incorrect. So P is less than 7.8%. Okay. So there's our null and alternative. Now I'm going to draw my curve. Now since our alternative is less than, we know it's going to be a left tail test. And if you go to the little chart I had you copy on your notes, you should see that it is 2.325 is our critical value. 2.325, and since it is a left tail test, this is going to be negative. So here we have our reject area and fail to reject. Okay, so all that's the same as when we did our average. Now we need to find our pieces to find our test statistic. And what we have our P, which is right there. So I'm going to write all this stuff out. We have our P, which is 0.078, which means our Q, okay, 1 minus 0.078. So you can either have it as 1 minus 0.078, or if you want to do the calculation, it ends up being 0.922. Our P hat, we had 46 out of 821. And that should end up being 0.056. And our N is 821. So there's all the information you need. So take your time and plug that in. Okay. 0.056 minus 0.078. And in the denominator, we're going to have the square root of 0.078 times 0.922 divided by 821. Okay, now this one, I would say if you're going to plug this all in at one time, I feel like this one's a little more complicated than the test statistic for the average. Okay, I'm going to put my parentheses there. And I have, if you plug it all in, I have, now it's again, depending on if you plug it all in at once or if you do it bit by bit, I have negative 2.351. And we're going to go back to our curve and see where that falls. So negative 2.351. I haven't had a time where plugging it all in at once or doing it bit by bit changed your outcome or your conclusion at all. Okay, at least for the problems that we do in this course, so you should be okay. That negative 2.351 falls in the reject area. So we would reject the null. So remember what that means. Rejecting the null means that there is evidence to support the alternative. Okay, so there is evidence to support that P is less than 7.8%, or the proportion is less than 7.8%. So the bookstore owner really should not be upset. Okay, the bookstore owner is incorrect, saying that it's greater than 7.8%, and the claim that that mid-sized cars with airbags that get into accidents have less than 7.8% of their riders hospitalized. There is evidence to support that claim. Okay? So that was our example for the p-value, or sorry, for the critical value method. Okay? So go ahead and do some practice on that, and you should be good with proportions.